Rajneesh ji, sir, would you be required to share your screen as well so that I'll make you the co-host?
No. I do not require to be sharing any screen.
Right.
Our expert panels are sitting and would be sharing their knowledge from Bangalore.
Right. Perfect, sir. We are live, sir.
Okay, perfect. Can you see my screen also, the presentation?
Yes.
Excellent.
Yes.
So, a very good afternoon, everyone. Welcome to this first session of this Plump Skill event, which is going on. This is a 1-month event. So, we had the similar session earlier, but we felt that let's break that session into 3 parts so that we deliver as a program. So, this is basically session 1 of a 3-session program. In this session, we are going to discuss. Rajesh, you're planning to tell something?
Yeah, yes. Our chairman of IPSC, Mr. Somani, I think he has joined. So Ajit, can you please welcome Somani sir and just introduce Somani sir to the expert panel. Sunil ji, are you listening? Hello.
Yeah, good afternoon, sir.
Good afternoon, Sunil. I would request that Somani sir has joined. So I request you to introduce our chairman, IPSC, Dr. Somani, to the expert panel who are giving this presentation from their Bangalore operations.
Yeah. Avinash ji, we have along with us the chairman of Hindware, and he's also the chairman of Indian Plumbing Skill Council. And sir, he's a legend of his own, and he's in the industry from last many decades. So we are really happy that he's here, sir. So Avinash ji, you can start your presentation. So
Sure,
sir is here, Mani ji is also here.
Sure, thank you.
Welcome, Mani sir.
Thank you.
Yeah, thank you, Sunilji. I think namaste and welcome, Somani sir. I think it's our privilege to connect with you and speak with you today in a very important topic on water and wastewater. And thank you all for giving us this opportunity to be a part of this program. We as a company, we are driving thought leadership on water and wastewater recycle. So again, welcome you all for this first session of 3-session event, as I mentioned. So today we are going to discuss this 3 important topic. I think we'll make it a bit more interactive. So my name is Abhinash Patro. I lead the marketing and communication for Suez South Asia. Today I have Mr. Rajshekharan. So he's sitting with me in the same cabin. Yeah, here is Mr. Rajshekharan.
Namaste. Good afternoon, everyone. Yeah.
So he is going to take us through some detail on this very specific technology and the application which we are going to speak today. So yes, so this is the agenda. We have a bit tweaked this agenda with our session 1, and this is in session 1, ladies and gentlemen. We are going to discuss on a specific technology, the working principle of this technology, and we'll touch upon some of the case study. But next, the session 2, which is there in the next week, there we will deep dive more into some specific case study and some of the plants which is currently working, how the process is working, how the plant look like, what are the outlet parameters. So we will deep dive in the session 2, that is next week. Then in the session 3, we will have some real user experience, and we will discuss on some water treatment membrane product like RO and ultrafiltration, which you all will find applicable. So today, let's start this session with seeing the Indian water scenario. We all know this, but the relevance of this gets more importance when we discuss this again and again. So that we will discuss today. Then very important, the second point, I think, let's see the sewage recycle norms, okay, the wastewater recycle norms globally. So we will see where we are in India, what are the norms. globally, what are the norms and where we are in, from where to where we have to move? What is the future? This is very, very important. I need your complete attention, team, on this sewage recycle norms. Third, how to get that norms, which is globally the norms which everybody is driving. How we as a company, we can help you to get that recycle norm, to get that treated water quality which you all can reuse. Then we will see the benefit of one of our advanced technology, that is ZeeWeed MBR. Then quickly we'll touch upon some of the case studies, and in-depth case study we'll have in the next session. Okay, so let me start. Why water and why managing water is crucial. This we all know, but for the sake of its importance, let me repeat it again for all of you. First is the physical risk. We know the water availability, how it is decreasing day by day. The stress on our water body, the groundwater, we know everything. Because of this lack of water supply, plants are getting shut down, there is revenue loss and there are job loss. So there is physical risk and we have to manage our water. Second is regulatory risk. Please take it from me. Gone are those days where we can take as much as water as per our convenience. Government has started putting the cap on our freshwater resource, because fresh water we have to consume. First priority is for living. So the other day I was studying somewhere, without water maximum 21 days we can live. After that we are going to die. So government is diverting fresh water. First is for drinking also. Then the regulatory norms are changing, the discharge norms are changing. We have to recycle and reuse the water. And the fresh water, the other day I was seeing in Bangalore, the fresh water price, you will not believe, is 130 rupees per KL for industrial use. Just imagine how the fresh water price is increasing. So we have to go towards recycle and reuse, which price of recycle reuse is far less than the fresh water which we are getting. So this is important. And the reputation risk. One message in social media or in the press, like our plant is not working or it is not adhering to the standard or the discharge standard, we are going to have face problem, correct? So these are the important challenge. Now coming to India, with all this challenge, our population is going to grow up. We are having more industry. Urbanization, very important in this sector, is going to grow up, and it is only going to increase these challenges. Second point, India is ranked 128th among 122 countries in global water quality index. You can see nearly 70% of our water, the groundwater, is contaminated. So we have to treat it. Now currently only 30% is going any treatment. Third, very important, Niti Aayog has already said 21 cities in India, including Delhi, Bangalore, Chennai, and Hyderabad, will run out of groundwater. Very important. These are very important point. Again, because of that only I'm stressing. And last, as I'm mentioning, per capita availability has decreased. There is a clear deficit of fresh water even for drinking. So very important. We as a company, across global, from 162 years, our only ambition, vision, or whatever you call, purpose is to shape a sustainable environment now, to help all our industrial customers, urban customer, municipal customer to solve their water challenges with best-in-class technology. This is what we are striving, and because of this, we are leading in this industry. And how we are doing this? So these are the three pillars which I want everyone to remember and note it down. The first one is we are working with cities to reduce their water footprint. How much the water we are consuming, as per the research, is 3 times the water which is required. So we have to reduce our water intake itself. Second is integrated water management, where we have to reuse the water, recycle the water. And third, I think this revolves, all our discussion today is going to revolve in the third point, how we can create alternate source of water. By treating sewage, by reusing sewage, by treating wastewater, we have to create alternate source of water. And one model which is which is successful in India is decentralized sewage recycle solutions. So we are going to focus on this decentralized sewage recycle solutions today. So Suez as a company, as I mentioned, when our customers win, we win. So who are all connected? Our only intention is to make you win over these water challenges. As a company, I will skip some of the company introductory slide. So trust us, we are a 162-year-old company, started in 1858, and you all would have heard Suez Canal. So we have constructed this canal, and from 162-year-old, we are in this journey of providing water and wastewater solutions to our customers. Currently, we are a group of 90,000 passionate environmentalists, passionate engineers working with our customers to solve their challenges. And you can see by treating water, wastewater and waste, our revenue is 18 billion euro last year. So this is how, and more than 450,000 customers are working with us. They've given up their trust to us, and we are helping them to solve their recycle challenges. In India, ladies and gentlemen, we are there from last 40 years. We have developed with international advanced technology with the local expertise, and we have developed the people expertise, also the technical expertise in India from last 14 years. And you can see the middle one in this sector, the urban sector where you all belong, the architects, consultant, the plumbing ecosystem, we are providing decentralized water and wastewater solutions. And the main key takeaway from our technology is we are promoting minimum reuse standards. So the quality of water should be totally fit for purpose, and you can directly reuse those quality of water in your other applications. This is where we are promoting. We have a manufacturing facility in Hoskote. So we are in line with government's initiative of Make in India from 2009 itself. So where we manufacture our membranes and specialty chemicals. Now we will move to the second important point, the global recycle norms. I would like to bring your attention to this important slide. I think this is the main slide where you will see where we are there in India and where the globe is there. You can see India, as per our NGT norms, the BOD, what we have to achieve, the reuse standard BOD is less than 10, and the suspended solids is less than 20. This is as per NGT. But ladies and gentlemen, see where the world is moving. Just see Texas. This U means urban, like we all belong to urban sector. See how much BOD they are expecting, less than 5. So already countries are moving towards having an outlet BOD of less than 5. And you see Singapore, it's like 1 to 5. So these countries are moving towards more tighter norms, more reuse norms. Why? Because directly they want to reuse this water first. Second is they want to also recharge the groundwater with this recycled water, because this water is going to mix with our drinking water, with our potable water. So they have to make sure that this water quality is equivalent or better than the drinking water quality. And this is the reason how this country is moving towards more stringent norms. And now the next slides, we are going to see how as a company from last 40 years, already we have started working towards this global standard. Being a global company, we have a clear-cut information where the world is moving. And already in India, we have supplied more than 250 plants, achieving this more tighter norms of less than 5 BOD, this parameter. So on this specific technology, we will work today. And Mr. Rajshekharan is there with me. He's going to take us deep dive to this technology and how with this technology we can achieve this minimum recycle parameter. So Rajshekharan, over to you, sir.
Thank you, Avinash. Thanks for wonderful information about importance of the water and India. Where that India going going to have that all the challenges. Okay, with all the challenges, how Suez as a company we are going to help the India market. Okay, today I'm going to talk about especially then maybe the most of the people aware of that the new technology of MB or membrane bioreactor technology. I will talk about a little more on that. So how this will help to recycle your sewage water to the reusable water quality. So this is a fantastic the product line which is available across the world. Okay, how it has been over a period of time. This has been evolved actually over a period of time in the world. How the customers are getting benefited. This is what I'm going to talk about today. And this page. Yeah, I got it. Okay. So actually, this slide, MBR is nothing but it's a membrane bioreactor technology. it's most advanced technology of your conventional sewage treatment systems. So this technology started in 1983. Yeah, at that time, this technology was not it was not very famous, actually, I would say that. So 1983 it started. Then over a period of time, this technology has been adopted very well, especially last almost, I would say, the last 10 years. It has been accepted across the world very well. We just see that in 2020, so more than almost 20,000 mld of water, it's been treated with our new technology, new MBR technology. That means the ZeeWeed technology. It's been utilized across the world. You can see one of some of the biggest customers of like 864 mld with our MBR process. It's been followed. So like that, many processes been followed. So why I'm talking about these things, the technology has been very well adopted and adopted across the world, and also it's been very it's been very successful even in the India as well, actually. So just you can see that the dot in blue color across the the world, it's been adopted. Even in India, so most of the customers, they know about MBR technology, and also if they know MBR, that means ZeeWeed is one of the pioneer product in resolving all their water challenges, both on the sewage and as well as tough effluent side as well. And in India, we started our first plant in 2004 at a Kaban Park. I think many of you knows about this Kaban Park, this plant, and from there actually our journey started in operations. So as a company journey started with the MBR technology, which is the advanced systems. And right now we have a more than 800 installation across the world. It's across the India, it's available, and across the world more than 2,000 installation it's available actually. And with the 800 installation, more than 225 mld of water every day it's treated with its ZeeWeed process, and it's been reused for complete all non-potable applications. And in that MBR segments, Suez has the maximum market share of around more than 70%. Okay. So this comes from all the trust from the customers. Okay, they used our product line, and it's not only one time they used. Once they used, and and again and again they have used. So some of the customers I'm going to talk about today. So more than 25 plants in their campuses they have installed with MBR systems, and some of the customers they installed more than 15 plants with our technology. That means all the customers understood that importance of the wastewater recycle, and only the trusted brand, that means ZeeWeed 500D product lines. So now I'll just talk about a little bit what is maybe. So we are all talk about advanced systems and all that. So how it works, when you are comparing with the conventional way of treatment process. So MBR is nothing but a membrane bioreactor process. So this is a basically combination of your conventional biological process as well as the membrane filtration process. So this is what has happened actually. After bioreactor tank, it goes into your membrane system. In the membrane process, just the clear water only will be sucked out, and existing the all the sludge and maybe the BOD and COD, everything it will get filtered by the membrane process. So the membrane can produce only the clear water, and it acts as like a complete barrier, and it gives you only the consistently good water quality which can be reusable for all non-potable applications concerns. Okay, so then what is the comparison between, if you are comparing the conventional systems versus our MBR process? Conventional typically follows screens, aeration tank, and then secondary clarifier, then clarified water tank, sand filter, carbon filter, then ultrafiltration to get the reusable quality. But whereas when it comes to MBR, you don't require a secondary clarifier, you don't require a clarified water tank, even sand filter, even you don't require a carbon filter, even you don't require ultrafiltrations also. So what we will do with the MBR process, that means, so we are going to reduce all the process and make it into very simple and very simplest solutions. And also see, we can see that we require only fine screen, and the aeration process, part of aeration process, the membranes will be installed in the same aeration tank, or as well as separate membrane tank as well. Okay, from there we'll suck the water, clear water, and this water can be completely used for all non-potable applications, like a cooling tower makeup or gardening or toilet flushing, any process can be used. So by reducing all this process, already started saving your footprint, and also there is so much of equipment and complexity, everything it can save. Okay, in today's world, in the urbanization, so the space becomes a very, very critical. If you talk about main cities like Mumbai or Delhi or Bangalore, the per square feet goes up to 30,000, 40,000 rupees per square feet. But when you are saving so much of space with an advanced technology, so the return on investment, you can get it very, very quickly. So this is a simple process of MBR, bar screen and oil skimmer, and the equalization. Then it followed with equalization tank. Then fine screen. The fine screen is the one we mandatorily provide, because of this, especially the human hair, and as well as some blades or some kind of pins should not go on damage the membranes. After fine screen goes to the biological process. Biological process is common for both conventional as well as our MBR process as well. Then we introduce the membrane filtration process. Instead of clarifier and all this process, we introduce membrane process. From there, we take out only the clear water, excess sludge, it will be returned back to your biological process itself. So that overall, the complexity or the space required, everything it reduces, and will get a consistent outer water quality. So you can just compare small comparison between the conventional process of any STP treatment, sewage water treatment, and versus MBR process. You just required less than half of the space. The red color, which we are showing it over here, it requires small space only for the same similar capacity of the of the plant. Okay, so just imagine half of the space, if you are able to save it especially in the cities like all the metropolitan cities, you can save huge amount of cost. Correct. So this is a technology which is available. Yes, most of the people are aware of about it, but now the awareness needs to be increased, so that every STP should come with this is the advanced technologies like MBR technologies. Okay. So it's not only that it saves this space for the new plant, and also for the existing plant. If you're already having a plant, we wanted to increase the capacity or enhance the capacity, we can easily retrofit with the MBR process, this membrane bioreactor process, and easily we can increase the capacity to up to 3x times. Say for example, somebody has that what we have proven across the India. Say for example, somebody has 300 KLD of STP treatment plant, which can easily increase it to 1000 KLD of plant. So 3 times you can easily. Some cases even we went to 4 times also. It all depends on the space availability. But what I could say that even the existing capacities, you can easily increase it to even 3 times and above only. And which will reduce your additional civil requirement and space requirement. And also not only that, also you get a consistent outer water quality at all the time of operations. Okay, so this is a beautiful technology, and it has been adopted across the India. And recently, if you just say that even for a 5 KLD to 10 KLD also we have a membrane. I'm going to talk about this right now. So what is that? We talk about consistently outer water quality and all that. Just you can see that NGT norms. So NGT norm says BOD less than 10, but whereas our MBR process, which can give you less than 5. Just imagine how best water quality the ZeeWeed MBR process is going to give you. And similarly, like a COD, 50 is as per the norms, maybe 50 after ultrafiltration, but with the MBR process less than 30 you can get it. Similarly, like a TSS, less than 2 you will get it. So that means it's complete water. It's a reusable quality, and except drinking and bathing, it can be absolutely used for all car wash, cooling tower makeup, fire hydrant, your flushing, gardening. So completely this water can be used, as Avinash explained. So the water, you can save it, because of day by day, the water scarcity is going to go up in India. So with this new technology, requirement for any, be it apartment complex or only. So why is this membranes are very, very famous? This is a patented technology of Suez. Okay, this both on the fiber as well as potting technology, and this is actually made by one of the best polymer chemistry of PVD, a polyvinyl fluoride chemistry, and which can withstand much longer life. Longer life means normally this membrane's life comes for typically 8 to 10 years of life. So you don't need to, once you install, you need to change the membrane for minimum of 10 years. Where we have in India itself, we have a reference of more than 12, 13 years, the membrane not replaced and still it has been working for a long time. And also we follow the process of out-to-in technology. It's excellent flow path. It reduces all the blockage and everything, and also it can operate at the wide pH range. And then this is a normal pore size is 0.04. That means what? It can reduce your all bacteria, turbidity, virus, protozoa, everything. Today the world is completely afraid of the virus, right? Everybody knows that, right? So even that virus, 99.99%, these membranes can be removed from your sewage water or maybe your drinking water application is concerned. So this is going to be, this will give you complete safest water for all the including the non-potable application. Somebody drinks that water where the gardeners they're using this water completely. Somebody unknowingly touches or maybe drink it, also nothing will happen. That means this removes complete bacteria and virus from this sewage systems. So this also I talked about the long life. Actually, this has a highest strength of more than 600 newtons. And already discussed about this is made by reinforced fiber by PVDF technology. So now earlier I talked about for the lowest capacity of MBR system. Earlier actually, if you come and ask maybe 3 years ago, so do we have a capacity of less than 50 KLD MBR process? At that time we would have said that no actually. But right now we have a membranes available from 5 KLD onwards. 5 KLD means what? Maybe the apartment complex, okay, of maybe 5 houses in a small community, or maybe 10 houses in a small community, which can produce approximately 5 to 10 KL of the sewage water in a day. Even such a small apartment complex can treat with the advanced technology of our MBR process, ZeeWeed 500S process. So these membranes, we have introduced very simplest membrane. This can be inserted into single tank design, which saves huge amount of space. And we can just see that what is the area required: 1.7 meter height and 0.2 meter width and 0.3 meter almost depth. So that means imagine this is such a small, very compact membrane. You can just put it into the sewage, the STP in the aeration tank and start sucking the water. So that you can save huge amount of space, as well as you can get the consistently very good outlet water qualities. Okay, so this is actually fantastic. One more additions, with this new membranes. Earlier we required minimum height of around 8 meters. So especially in the apartment complex, it's very difficult to get it, and especially in the buildings below the basement and all, very difficult to get 8 meters. But with this, the new membrane, introduction of new membrane, we can reduce it to 5 meter only. So even sometimes, with the 4.5 meter also, we can easily retrofit with our MBR process. So just imagine actually around 38% of the space it's been reduced, when compared to the earlier MBR process and then the new MBR process basically. And now I'll talk about the small flow, of 5 KLD to 300 KLD. So this is the simplest form of membranes which is available. And now, since we have installed more than 800 plants across India, we have the complete experience. So anybody ask, or even small OEMs, system integrators can easily install the 5 KLD to 300 KLD plant. So we have the complete backup plan from Bangalore office, which can provide easily on the drawings and committing support and all that actually. So this is actually up to 150 KLD. It's not only we supply the membrane, and also it is like a completely packaged unit, very compact packaged unit. Say for example 150 KLD of the plant, which requires only 8 by 4 meter of the dimension. So within this area, we can easily fit into that a complete STP plant. So I was talked about the less than half of the space only required when compared to the conventional system. Just imagine actually 150 KLD, so 8 by 4 meters. So how much space we can save it, right? So this is advantage of the biggest advantage of the ZeeWeed 500S product, and it's not only that consistently you get good water can be absolutely reused, and it can be you can get the return on investment typically 2 to 3 years of time. Even some of the cases what we have proven in less than 2 years that in return on investment it's been given to our customers. So this is some of the examples where our membranes are installed, and it's like kind of it's hanging. And this is some more photographs where our ZeeWeed MBRs installed. See, just if somebody wanted to remove only one membrane, you can just close the tap and remove the pipes. You can just easily remove it, and you can clean it. You can put it back into the system. During the cleaning of the membrane, still your process can be you can do the continuous process. So you don't need to stop the plant, and at the same time you can clean the membranes as well. So this is the biggest advantage of this process. And also in addition to that, the skid-based systems also we provide. So we have seen in one of the plant is in Hyderabad. So 1.1 MLD of plant with with a small skid of say around 3 by 7 meter, actually 7 meter by 3 meter width. So we have installed. So right hand side, you can see that the membranes, membrane tank and the cassettes are installed in that. So this can produce approximately 1.1 MLD of flow. Now you can compare with your existing process of any conventional process, either SBR, MBBR, versus MBR process. How much space it saves to the customers, and in addition to all the benefits which I talked about earlier. So this is actually chart how that virus or maybe the overall where that virus it's been falling. So our membranes, as earlier talked about 0.04 micron the pore size. So it removes all the virus, bacteria, and everything. Right hand side, whatever it's showing here, bacteria, protozoa, virus. So all that it can easily filter. Okay, with our membrane technology, that means this water can be absolutely used for all non-potable application without any further process. If somebody wanted to drink, take it for the drink for drinkable water quality, then RO may be required. At that time, easily, you can put that RO and you can start taking it for all, including the drinking or maybe bathing purpose also. Especially in Singapore, if we go to Singapore, there is a water called New Water, and the New Water, it's been partially mixed the treated sewage into the drinking water, almost 33% of it. And in that process, our MBR, ZeeWeed MBR, it's been used, and MBR outlet water only goes for, after the multiple process of treatment, it goes for the drinking purpose as well. So that's all from my side. And so any doubt or any clarification, please reach out to us, and Abhinash will take it forward for the next case studies. Thank you very much. Yes.
Thank you, Mr. Rajshekharan. So now we will discuss. We have seen the technology, the parameter, the application. So we will discuss two case study, not in very detail, but a very macro level. The in-depth analysis of this case study, the actual results which the customer are getting, also the savings that we will discuss in the session 2, which is next week. So again, connect with us. But let me discuss two case study now on a very macro scale. So this plant we have supplied to IIT Hyderabad. So IIT being a premier institute, they are always very much particular on what kind of advanced technology they can use, how they can improve on the technology. And so IIT wanted to recycle and reuse 650 KLD of sewage, which currently being generated from various sources like from their hostel, from their offices, and they want to reuse every drop of this sewage water into gardening, toilet flushing, and also chiller. So this is what the plant we have given. You can see the plant here. This is basically a 650 KLD, but it can be also expandable to one more 650 KLD. And you can see how beautifully this plant is designed with collection tank, with screening, oil and gas trap, equalization tank, anoxic tank to remove NNP, then bioreactor and the MBR tank. So this is the plant which we have given at IIT Hyderabad. You can see this is the MBR tank, where this is the heart of any sewage treatment plant process, where actually the biological process, which Raja just now explained. And this is the feedback from IIT director when I met him. So one of the strong reasons why we wanted this kind of technology is many times you observe that gardeners, while watering the plant, they consume the water for drinking or maybe for washing their face. So IIT also wanted to take extreme care of those gardeners, those people who are touching the sewage water. That's why this is one of the reasons they've gone with MBR technology, because as Raja mentioned, MBR means you are going to get high quality reused water. So this is a plant at IIT Hyderabad. We have a complete video of this plant, how the plant works, which we are going to show in the subsequent sessions the next week. The first plant is IIT Hyderabad. Second, again, this is a plant for a complete township. This is for Pallava city in Mumbai. This plant is for Lodha Group. So Lodha Group is one of the leading real estate developer in India. They wanted to again recycle every drop of sewage which the township is generating, so that they become very important self-sustainable. They wanted to reduce the fresh water intake. They wanted to be self-sustainable. They wanted to be water positive. I'll tell you how they become water positive. Currently, Lodha is totally recycling the sewage, and as a CSR activity, they're supplying this treated water to nearby pharma and chemical industry. This is how they become water positive. They've reduced their fresh water intake more than 50%, and every drop of sewage Lodha Group is using. So again, this case study, we are going to again go one level down. What is the process? What are the real benefits? What is the area consumed? In our next subsequent session. Also, we will also show you a live interview of Mr. Sheshav Dharia, the CEO of Lodha. What is his views on using advanced technology for sewage recycle, on using decentralized technology. So we will live see his views also in our next session. So this is on the Lodha. Ladies and gentlemen, we have recently launched a new offering called In Sentinel, very much relevant in the current scenario. If you want to make sure that your society is safe from COVID or your office is safe from COVID, then we can test the presence of COVID-19 in the wastewater. Because wastewater, if there is COVID-19 in our body, then it is going to go through the wastewater, and it has been confirmed by many reports. So by testing the presence of wastewater in COVID-19 in wastewater potential presence, we can tell you whether your society is infected or it is safe. And this is very cost effective. So you can see, and important is, this is an early indicator. So we should not wait, okay, now there is a COVID-19 is going and we will take action. So it is an early indicator of COVID-19 now. This is a very important offering which we are offering, very minimal cost and very fast and reliable. So this is on the In Sentinel. Now over to all of you for any questions which you have in the top of the mind. Also in the next session, I again invite you all of you to join us again, where we will have a detailed deep dive analysis on some of the 4 or 5 case studies on sewage recycle and reuse. So over to everyone for any questions. So myself and both Mr. Raja, we both are here to answer your question.
Yeah, good afternoon, sir.
Good afternoon.
Hello.
Yeah,
good afternoon.
I can hear you.
Yeah, can you hear me?
Yes, very clear.
Yes. Sir, my one challenge what I faced in this effluent treatment is sludge management.
Okay.
So you have got any specific solution for this sludge management?
Yeah. I think it's a great question, sir, actually. Especially, in fact, I know one other point I missed to talk about, the sludge management. When you are talking about, when you are comparing the conventional system versus MBR process, the MBR process, it's operated at, very high MLSS, the value in the bioreactor tank. That means normally conventional system operate at 3000 MLSS. And when it's getting discharged in the sludge, it goes in the around 3000 MLSS. Whereas the MBR process, we operate at the 8000 to 15,000 MLSS concentration. That means you are concentrating the water almost more than 3 times when comparing with when compared to the conventional process. That means the total quantity of sludge when you are disposing it is almost like almost 3 times you can reduce it. That means normal conventional around say 15% of the 10 to 15% of the sludge you need to waste. When it comes for the MBR process, less than 2% only you need to waste. So that means this much amount of the saving in terms of operation of your sludge dewatering process, be it filter press or be it centrifuge, this will be more useful actually.
I think very, very nicely answered by Raja. So typically we have seen around 1 to 2% only the sludge we generate from this MBR plant. And after the process from filter press to centrifuge, directly as a manure, we can use this in your garden or in your other applications. So it is directly manure you are getting, and 99% of your water, it is back to your for reuse.
And when I say, you have reduced the sludge drastically, apart from, which is easily used as manure, then you have also tackled the another problem of solid waste disposal. Am I right, Ryan?
Very nicely pointed out, Rajnish sir. Very nicely pointed out.
Yes.
Thank you, sir.
Thank you.
Raja, I just want to know, for let us say the smallest plant when you mentioned 12.5 KLD plant, this means, in one apartment, you said, let us say apartment, 5 apartment block or 10 apartment block. So are you considering a family of 4 members per apartment? Means how are you considering it?
Yeah, so typically as per the Indian standard, actually per person, the wastage is considered around 150 to 200 liters actually. So 150 to 200 liters, it means, so even 4 person if stays in the house, so approximately 200 into 4 times 7, 800 liters per person. Okay, when we are our STPs, normally around 750 liters per family we take. Sometimes maybe 3%, maybe a 5% or 6% family also may be there. Okay, in this case, per person around close to 200 liters and maybe for family around 750 liters. See, but in this case, say 10 apartments are there in a small community. 10 apartments, but it's a 7.5 KLD of sewage every day it will get generated approximately. Okay, so that means even it's a small apartment complex can go for this advanced treatment systems. I hope I answered your questions.
Yeah. So when you are saying 150 to 200 liters, this is per day, 24 hours?
Yeah, per day, 24 hours. That's right. This includes your bathing, your toilet flushing, your washing, all the water.
Everything. And tell me one thing, if we consider on the institutional basis, like, you have shared the case study of the Infosys IIT like this, or let us say one office commercial block. So, offices normally they would work, let us say on an average 8 to 10 hours. Yeah. So in offices, for institutional, what is the benchmark you are taking as per person sewage generation?
Yeah, I think again it's a great question, Rajnish sir. Actually, see, you asked about the household, okay, and then office complex. Office complex normally we take the the water consumption of around 35 liters per day per person to around 45 liters per day actually. So especially IT and IT industries, or maybe that where the people use more water, we go up to 45 liters per day per person, or just the commercial buildings, like a person comes in the morning, goes in the evening, we take 35 liters per person. So 35, normally, for example, in the community, you are having a one commercial building plus, maybe say 100, for example, 100, residential complex. So for residential complex, we calculate based on 150 liters per person. And then when it comes for the commercial, 35 liters per person we will calculate. So that's how we will derive the capacity of the overall STP plants. Yes. Yes, sir.
I think Dr. R.K. Somani has a question.
Yes. Somani, sir, actually you have a question. Yes.
I want to know what is the ultimate cost of 1 MLD unit in terms of liters?
Sir, actually, if you are comparing with, because see, every plant, the cost, it varies, okay, depends on the place or depends on the pumping station or
average cost.
Okay, so, but when you are comparing with the conventional process, okay, I have shown you that presentation, right, up to reusable quality, it is easily comparable with the MBR process, almost the same, cost as, like your conventional process plus your ultrafiltration. That means that when you are wanted to bring your conventional process plus the reusable quality, what is the cost you are going to spend versus MBR, it's almost same. Maybe 10 to 15% here and there, it varies. But again, why I'm not giving the exact cost, sir, It is varies, depends on the space to space, or maybe that depends on the capacities. See, for example, if I design a capacity of 50 KLD versus 1 MLD, there is a huge difference in the per KLD cost. That's the reason I'm.
Take Loda for instance. Take Loda for instance. That unit is installed and working, I hope.
Yeah, correct.
Raja, you have to give a benchmark figure what Somani sir is asking, that per liter, what is the treatment cost? Nobody is going to, hold you responsible, but
okay.
Some benchmark figure they are asking.
Yeah, approximately per KL, we talk about 15 rupees per KL, the treatment cost actually, Somani sir.
Okay.
So
that includes the capital cost?
Yeah, approximately, yes. Yes, sir.
And then you got to, the inherent savings in regards to the area and all what you can save actually.
Yes, absolutely right, yes.
No, the reason I asked was not personal, but indirectly. I have a flat in Hyderabad in the Gachibowli.
Okay, sir.
Okay. And we residents are having so much problem with the owners. They are using some chemicals which we don't understand. And if we have an Hyderabad office, I would like some help.
Absolutely, yes, sir. Actually, very close to your Gachibowli site, Infosys 600 KLE, we have installed the plant, which has been operating for last 5 years. Okay. So, and also, Hyderabad, IIT Hyderabad, the plant has been operating for close to last 3 years. So, how many plants are there even in Hyderabad also?
No, the owners have already installed one, but we're not very happy with it.
Yeah.
The owner is not very happy.
Yeah. I think, probably they would have installed the conventional way of process, sir.
I have no means of finding out that they won't let me see anything.
Yeah. Sir, actually, do let us know. Actually, we can visit your site. Okay. We can help you on that. We can resolve your issues, sir. Actually.
Thank you so much.
Thank you, sir. Yeah, thank you.
So just a question that has come through. So the session is actually being played live through Wikibike platform as well. There's a question that's come through. I think there are some plumbers that are listening as well. One of the plumbers has asked if they would like to learn about the technology. Where can they do so? And is it something that a plumber can actually learn as well? And I'll just kind of add something from IPSC side as well. I represent IPSC. And a question from my side would be, in terms of the manpower that is used to, let's say, install and operate the plants, what is the requirement that is there? And do you think a plumber can actually get trained on such technologies as well?
To answer your simple one-word question, absolutely yes. Okay, any plumber, the person who can able to read English, he can easily operate this plant. This is not a very complex process, very, very simple process. Even with the conventional process of, to treat the conventional process, people require to have, a lot of expertise. But here, since it is a membrane-based technologies, it is absolutely very, very easy. I can, in other way, I'll put it in other way, like how earlier we were using button phones. Now we are everybody using smartphones like this. It's absolutely very easy to install this plant, or any plumber also can easily install with our guidance. And if you further more information if you wanted, I think the email IDs and phone number is given in the same page. And you can please reach out to us. We will very well, connect with all plumbers, and we can, give the training to them actually.
Mr. Patra, the reason I was also asking on behalf of IPSC was because we actually do a lot of training and certification of the plumbing workforce under the Skill India mission. We work under the aegis of Ministry of Skill Development, and Rajneesh sir, Dr. R.K. Somani, Rajiv sir, they're all part of IPSC. They're the board members as well and the directors. The question, of course, from our side was, if there is a training program, we would like to see how we can take this forward together and kind of build some courseware for the masses that they can learn as well. Rajneesh sir, I'd like to take your comments and inputs as well, sir.
Very well said, Varun. Unfortunately, during that last session, when Mr. Vinay Gupta was also there, our chairman, you were not there. You were a little, down with some health problem. So this is one thing what Mr. Vinay said is that, we need to include this, and we need to work out how these plumbers also can get benefited. And, it is, Suez would also understand and agree to this point that this is a win-win situation for all. For us at IPSC, the winning situation is that, we are creating another skill set for the plumbers for whom we are working actually. For sewage, it comes as a win-win situation because their technology is getting, more awareness, and it is getting exposed to people. And like Raja has said, uh, since it is, I would make it a very simple version like people talk today, plug and play technology. So they can easily work on it. All the plumbers can work on it. And whether English or Hindi, or I may say somebody like, Avinash, who speaks, I would say, very good English, actually. Because you have to get the point, your view, across to the people, and they will understand. It is so simple.
True. And Varun, we are totally excited to be a part of those training program. And we have a set of trainers here with Suez, and we can like assign a perfect technical trainer, and they can train the people. I think we are excited towards that, Varun.
Varun, as I know Suez, I'm using their diary, and on that diary, it is written a drop of genius. So these two people, actually, what you are seeing on the screen is a drop of the geniuses who are there in Suez. So this is a phenomenal resource in Suez, actually.
Thank you.
Great. Thank you for the answer. Thank you for your comments, Rajneesh sir. Chairman sir, with your permission, we would like to get started with Suez as well, sir, in a big way.
Of course, I'm agreeable.
Great,
sir.
Great opportunity for us. Win-win situation for both.
True, sir. So, Varun, I think this time you can make the remarks, and as I would say, once again, I will use what is written on the Suez diary, a drop of genius. So this session was just a drop of the geniuses, and the next coming sessions will be more, I would say, creating more ripples, actually. Thank you, Raja. Thank you, Avinash.
Thank you, everyone. Be safe. Take care.
Thank you, Raja. Thank you, Avinash, for such a wonderful presentation.
Thank you.
We hope the audience enjoyed it as well. On behalf of IPSC, FICCI, Plump Skills Expo, we thank you again for your time and the efforts. And watch this space. There's a lot that's going to be happening very soon.
Yes.
I think, sir, of course, technically, you'll have to pardon me the lack of technical knowledge on this subject, but we're looking forward to a joint collaboration in this front and taking this forward in a big way, sir.
Sure. No, the fact that you joined, you learned something.
Bilkul.
Yes, very true.
Okay.
Thank you.
Okay. Thank you.
Thank you.